on, right? And that thing, the type of message is statically known, right? So I will be sending this struct, which has data and an error type on it. In Erlang, right, Erlang's dynamically typed, so the process IDs, you can send whatever type of message. But Erlang is a little bit more flexible in that you can do like dynamic code loading and replace functions at runtime without restarting. In Go, you can't do that. There's always a trade-off, right? It goes much faster and has the typed messages, but you don't get the dynamic code reloading. Channels can also be blocking in Go, so you can say, if you ever study networks, flow control is a big thing, right? This was mentioned in one of the presentations earlier. They used a different term, but the idea is that if the producers are producing faster than the consumers can consume, the consumers need to have some flow control, and they can say, whoa, everyone chill out for a minute, right? Back off, I'm not going fast enough. So what you can say is this channel can hold 20 messages, and that will throttle, right, that left arrow operator. If that channel is full, will actually become a blocking operation. So it'll wait until someone reads off that channel, so then it will go ahead and be able to write to that channel. In this case, right, we've got our route. We'll make a channel. The channel's typed, so the way that you do that is the keyword chan, and then you put the type of the message that channel will be sending and receiving. And then in this case, the limit, right, we only want to have 20 at a time. And then you'll notice that there's no parentheses around the for. Same thing is true around ifs, the conditionals. In Go, they said, that's extraneous syntax. You don't need it. Why? It's just for something and then the curly braces, and turns out they're right. And it reads pretty well. In this case, this cons is an array, so you call range, pass it the cons